Sup, peeps? I have South Park episodes to watch, but it came to my attention that I have missed some easy problems. So they were stuck as attempted, but I couldn't do them because they were private. So what? Attempted. That's a strange symbol, but okay, let's take a look here. They're not private. They were you had to pay for this service, but now I paid for it. So, given an array of strings, words return true if it forms a valid word square. I've attempted this. This is not looking familiar. A sequence of strings forms a valid word square if the kth row and column read the same. Kth row and column read the same string, where 0... Oh, so first row, first column. Okay, so first row and first column both read A, B, C, D. Second row and second column BNRT. Oh, okay. Therefore, it's a valid word square. Max rows, max columns. So by definition, they would have to have the same number of columns as rows, right? Right? Well, we'll code it as though that's the case, and if we have to change it, then we have to change it. So apparently I started writing this. Alright, so, well, here. If words of I, if the length of that does not equal the length of words, then return false. N equals length words. No? No, I am making a mistake. I am making a terrible, terrible mistake. How does this work if it's out of bounds? How does it work if it's out of bounds? I guess it's just a blank? Stupid problem. Please don't forget to check boundary conditions. That the dimensions are equal in rows and columns. What an annoying question. I'll thumbs that up. I just added some dashes to the strings to make it easy. Okay. Alright. While length of words is less than n, we'll do this. Words dot append space, I guess. Space times n. All right. And then for I in length words, if words of I equals words of I plus space times n minus words of I. There. That was the difficult part, right? Now we can say for I in range n, and column word is just words of I, or we're going to call that row word. Column word equals I don't want to do it like that. That's stupid. Okay, so for j in range n, we're going to say row, if row word of j does not equal, we're going to be going down the column, right? So words j I, return false, otherwise return true. Int object is not iterable. Don't know why I stared at that like an idiot for a second. Okay. Output true. Oh, God. No. No, it's right. It is right. Okay. N equals max of length words for W in words. N equals max N length W. Use test case, run. And what? That was really stupid. Okay. Almost regret doing it. Okay, count triplets with even XOR set bits. Now that's interesting. Given 3 integer arrays A, B, and C, return the number of triplets A, B, or A of I, B of J, C of K, such that the bitwise XOR of the elements of each triplet has an even number of set bits. 100 times 100 times 100. This should be able to be brute forced, right? Such that the bitwise XOR of the elements of each triplet has an even number of set bits. For I in A, for I in A, for J in B, for K in C, V equals A, B, C, dot bit count, try bit count. Haha. Yeah. So if 0 equals V mod 2, in other words, if it's even, then T plus equals 1, return T. Why did I attempt this instead of finishing it? Exported operand type, list and list. List and list. Oh. Well, all right then.